We're going to move on to quadratics now, which is probably an even more important unit in terms of the IB exam. There are questions that will be just about quadratics, but mostly quadratics is a skill that you need to know for solving problems across many different topics. Okay, so what is a quadratic? A quadratic is basically an expression that has the form ax squared plus bx plus c. So you have a square term, a linear term, and a constant term. So for example, 3x squared minus 1 is a quadratic, but 2x plus 3 is not, because there's no x squared term. And there also can't be any higher terms than x squared. There can't be any x cubed or any x to any other power, just x to the power 2, x to the power 1, and a constant term. Okay, one of the most important things to know how to do with quadratics is how to factor them. And factoring a quadratic means essentially breaking it down into two terms that multiply together to give you the quadratic that you're talking about. And for now, before we talk about how to actually do that, you should just be aware of how to expand from a factored form to a quadratic, which is basically to multiply out the brackets. So I take my x times x squared, x times 3, 3x, negative 2 times x is negative 2x, and negative 2 times 2 is minus 6. And if I multiply everything out, I get 3x squared plus 3x plus 18. Minus 18, that is, sorry. We can go the other way by trying essentially to factor by inspection. So let's say I have the quadratic 3x squared plus 8x minus 3. I want to split the 8, the middle term, into the sum of two numbers, n plus m, such that when I multiply n times m together, I get negative 9, because I want 3 times minus 3 for the product. And I can do that by choosing n is equal to 9 and m is equal to minus 1. This system for factoring quadratics is a little bit of guesswork, and we're going to go over some different ways for doing that are a bit more systematic. But if you like this way and it works for many people, it's probably the fastest way to do it. So once I've seen n is equal to 9 and m is equal to minus 1, I split the middle term, the 8, into plus 8 plus 9 minus 1. So I do 3x squared plus 9x minus 3. And then that's going to allow me to identify some common factors. So the first two terms, I can factor out 3x and write 3x times x plus 3. And then the second term, I can factor out minus 1 and do minus 1 times x plus 3. And then because I have x plus 3 and x plus 3 is a common factor, I can factor that out, and I just get 3x minus 1. I get this 3x minus 1 times x plus 3. And what does that mean? It means that this quadratic is going to be equal to 0 either when x is 1 over 3, when this term is equal to 0, or when x is equal to minus 3, when this bracket is equal to 0. And we'll talk more about the connection between roots and factors in a second, but basically, if either of the factors is 0, 0 times anything is 0, which means that if the inside is 0, the quadratic is going to be 0. 2x squared minus 5x plus 3, and we were trying to do this by inspection, which means we're looking for n and m, so that n plus m is equal to minus 5, and n times m is equal to 6. So the numbers we're going to choose are n is equal to minus 2, and m is equal to minus 3. Because I add those together, I get minus 5, and I multiply them together to get 6. So that means I split my minus 5x into negative 2x and negative 3x. So 2x squared minus 2x minus 3x plus 3 is equal to 0. So now in the first two terms, I notice I can factor out 2x, so 2x times x minus 1. And in the second term, if I factor out x, then I get minus x, or sorry, if I factor out 3, minus 3 times x minus 1 is equal to 0. So this becomes 2x minus 3 times x minus 1. And that is option number 1. All right, so the second method that you need to be familiar with when it comes to quadratics is what's called completing the square. And completing the square is basically just a method for turning the quadratic into a specific form. And that form is written something like a times x minus h all squared plus k. So we're going to have something times some term squared plus or minus some constant number. And the advantage of this form is going to become more obvious when we talk about the vertex of a parabola in a little bit. But for the moment, I'm just going to show you how this works, and we'll kind of connect the dots later. So it's easier to work with an example, I think, than trying to do the formula in general. But imagine you have the quadratic 4x squared plus 16x minus 9 is equal to 0. All right, and I want you to focus on the 4x squared plus 16x part, because the 9 we can kind of deal with in a second. And the key thing to think about first is factoring out as much as you can from the x squared term. If I factor out 4 from the x squared, so I'm left with 4 times x squared plus 4, then if I think about x squared plus 4 as being the expansion of x plus something to the power 2, I know that when I expand, let's say, x plus a squared, I'm going to get x squared plus 2ax plus a squared. And so I want that 2a to match whatever the coefficient of my x is here. In other words, I want 2a to be 4 in this case, which means my a has to be 2. So I'm going to take x plus 2 squared is what I'm going to square so that I get x squared plus 4x. But the issue is if I square x plus 2, I'm going to get this extra plus 2 squared, or plus 4, that I didn't have on the left-hand side. And so all I'm going to have to do is just put a minus 4 outside the brackets to cancel the difference that I just made. And that means that I can write 4x squared plus 16x as 4 times, in brackets, x plus 2 all squared minus 4. And if I plug that back into my original equation to replace my 4x squared plus 16x, I can write the whole thing as 4 times x plus 2 squared. Then I'm going to have 4 times minus 4 is minus 16, and I'm going to subtract 9 to get minus 25. Now, once you're working in this form, it's pretty quick to find the roots of the quadratic, because if I simply equate it to 0 and I move the negative 25 to the right-hand side, I get 4 times x plus 2 squared is 25. And that means that x plus 2 is plus or minus the square root of 25 over 4. So what I've done there is I've divided both sides by 4, and I've taken the square root, remembering that because a negative number squared is the same as that positive number squared, I have to put a plus or minus in front of the square root. So you do that any time that you take the square root of both sides, you need to have your plus minus. And then because the root of 25 over 4 is 5 over 2, right? Because 5 squared is 25 and 2 squared is 4. I have x is going to be plus or minus 5 over 2 minus 2. So either 5 over 2 minus 2, that gives 1 over 2, or negative 5 over 2 minus 2, and that's going to give me negative 9 over 2. Okay, again, what I'm going to start by doing is focusing on the 2x squared minus 12x. I'm going to factor out the 2, and that's 2 times x squared minus 6x. Okay, and I'm going to write that as 2 times, if I want to get something that starts with x squared minus 6x, I can consider the expansion of x minus 3 squared. The problem is when I expand x minus 3 squared, I'm going to get x squared minus 6x plus 9. So I'm going to have to cancel out the 9 here by subtracting 9. So this becomes 2x squared minus 12x is equal to 2 times x minus 3 squared minus 18. And now, because I have 2x squared minus 12x plus 11, if I add back 11, I get 2 times x minus 3 squared minus 7. Quadratic formula. This one is super important, but it is in your formula booklet. But it just gives you a kind of systematic way of solving quadratics in general, no matter what quadratic you have. And essentially, if I have a quadratic ax squared plus bx plus c, and this formula can be proven actually by completing the square on ax squared plus bx plus c, you'll find that the roots of a quadratic in general are given by this equation. I'm not going to read it out because it's a little bit messy, but instead I'll just show you an example. So if I have 3x squared plus 4x minus 2, I can plug in my b term is 4, so I'm going to have negative 4 plus, and I'm going to do the square root of b squared, so 4 squared 16 minus 4 times 3 times minus 2, all divided by 2a, so 2 times 3, and I get negative 4 plus or minus the root of 40 over 3, and 40 is 4 times 10, so I can take out the square root of 4, which is 2, so negative 4 plus or minus 2 over root 10, and I divide on the top and bottom by 2, and I get the most simplified answer is minus 2 plus or minus 10 over 3. So I'm going to use my quadratic formula, which says that x is negative b, in this case 7, plus or minus the square root of b squared, so negative 7 squared, minus 4ac, so minus 4. In this case, a is 1 and c is 8, all over 2. So that's going to be 7 plus or minus the root of 49 minus 32 over 2. That's 7 plus or minus root 17 over 2. Like that. Okay, option number 1. Okay, so this question we're actually going to do with a calculator because some quadratics are a little bit too messy or the coefficients are too large to solve by hand. It's very, very difficult to factor this by inspection, and it's also difficult to use the quadratic formula because the numbers are just so large. Fortunately, the TI-84 and most other calculators that you'd be using for the IB have an app that you can use for solving not just quadratics, but actually polynomials in general. But I'm just going to show you how this works for quadratics. If you go to apps and you scroll down to, on my calculator, this is option 9, but it might not always be the same on yours, but you're going to go to PLY SMLT2, and you're going to go to option 1, the polynomial root finder. And here you're going to be prompted with a screen that allows you to pick the order and all these options, real, auto, normal, etc. The only thing you really need to focus on right now is the order of the polynomial, which basically in our case is going to be 2 because we have x squared, or the highest power of x being 2. So we're going to set x squared. I'm going to hit graph to go next, and I'm going to enter in my quadratic. So I have 16 for A, then I have 38 positive for B, and for C, I have negative 95. And I'm just going to hit graph to solve. And I'm going to find two solutions, 1.52 and negative 3.898. And if I round those, I'm going to get 1.5 and negative 3.9. So that should be option 4. Nice. Let's talk quickly about the discriminant. And this is a super common way that quadratics show up on the IB, is questions regarding the discriminant. So if you look at this term that's under the square root in the quadratic formula, b squared minus 4ac, we call that the discriminant. And one important thing to remember is that I can't take the square root of a negative number. In higher level, we'll talk about complex numbers in a couple of weeks, but at the standard level, there's no real number that's the square root of a negative number. So if my discriminant is negative, then this formula essentially is going to break. It's not going to give me real values for x, and so you're going to get no real solutions. In a similar way, if I have delta equals 0, if the discriminant is 0, then doing this plus or minus, the square root of 0 is just going to be 0, and plus or minus 0 is the same thing. I'm just going to have negative b over 2a. So when I have delta equals 0 and the discriminant is 0, there's only going to be one solution to the quadratic. But in general, if I have the square root of a positive number, then I'm going to do negative b plus or minus a positive number is going to give me two possible roots. So the discriminant is the quickest way to figure out how many roots your quadratic has, how many real roots. It's either going to have no real roots if delta is less than 0, it's going to have one real root if delta is 0, or it's going to have two real roots if delta is greater than 0. So let's take a look at this quick example. For what values of k does the quadratic 2x squared minus 3x plus k have two real roots? Okay, so the discriminant is delta is equal to negative 3 squared minus 4 times 2 times k is 9 minus 8k. So if it is two real solutions, then 9 minus 8k has to be positive. And if I rearrange that, it means that k is less than 9 over 8. I'm going to compute the discriminant of this quadratic, and it's going to be delta b squared minus 4ac, so minus 4 squared minus 4 times 1 times 2k is equal to 16 minus 8k. Okay, so this is going to have two real roots when delta is positive. So 16 minus 8k is greater than 0, which means that 16 is greater than 8k. So 8k is less than 2. Okay, and that is option number 4. All right, part B. When is this going to have one real root? That's going to be when 16 minus 8k is equal to 0. That's when k is equal to 2. All right, and it's going to have no real roots when 16 minus 8k is less than 0, which means that 8k is greater than 16, so k is greater than 2. Perfect. And you'll notice, by the way, that the answers to part A were k less than 2, k equal to 2, and k greater than 2. These answers have to complement each other. If I take the regions where delta is positive, then when it's 0 and when it's negative, they're going to line up in terms of the borders between them. So it's a little shortcut to going a little faster here. I want to talk now about parabolas and the graphs of quadratics. So a parabola is the shape that a quadratic equation would make if I plotted it on the Cartesian plane. And they look a little bit like satellite dishes if you look at this bit. And that's for interesting mathematical reasons that we're not going to talk about today. But basically, if you were to bounce light onto a parabola, all the light is going to meet at one common point, which makes it really useful for transmitting signals. But two important features to notice about the quadratic is that it is symmetric, right? There's a left side and a right side that are going to be mirror images of each other. And there's a vertex. There's either a minimum or a maximum point, depending on which way the parabola is pointing. It can be concave up or concave down, depending on whether the u is up or down. The x-intercepts of the quadratic are the values of the quadratic when y is equal to 0, which are just going to be the roots that we talked about earlier. So the x-intercepts, you can think of them in terms of the quadratic formula. Sometimes there's going to be 2, sometimes there's going to be 1, sometimes there's going to be none. It depends on the discriminant. And you can see that by thinking about, if I have my two roots, negative b plus minus square root delta, if I take the difference between the two roots, right? If I do negative b plus delta over 2a, and I subtract negative b minus the square root of delta over 2a, it simplifies to square root of delta over a, which basically means that the distance between the two roots of a quadratic is the square root of delta divided by a. And that should help you understand why when delta is 0, the distance between the two roots is going to be 0. So the roots are going to be the same. And if the square root is negative, then the square root is going to be undefined. It's not going to be a real number. And so you can't actually think about there being two roots. And you can see here, as the discriminant hits negative, you see the quadratic go above the x-axis and no longer have any solutions. All right, the concavity of a parabola, we talked about this a second ago a little bit, but it just describes whether the parabola is opening up or opening down. So a concave up parabola, the u of the parabola is pointing up, and a concave down, the u is pointing down. And whether a parabola is concave up or down just depends on the sign of a, the leading term. So if a is positive, we're going to have a concave up parabola, and if a is negative, we're going to have a concave down parabola. So concave up parabola means that a, the coefficient of the first term, is positive. So 2k plus 3 is greater than 0. So 2k is greater than minus 3. K is greater than minus 3 over 2. Okay. There we go. Now the axis of symmetry. I talked about a second ago how a parabola has an axis of symmetry. It's the line that goes through the vertex, and it basically is the mirror line of the parabola. And the mirror line, if you think about it, it has to be halfway between the two roots when there are roots. And so if you actually do that, you'll figure out that the equation of the axis of symmetry is x is equal to negative b divided by 2a. Okay, so the axis of symmetry is x is equal to negative b over 2a, or in this case, negative 2k over 2 times 3, that's 2k over 6, and that's supposed to be equal to minus 2. So that means 2k is equal to minus 12, k is equal to minus 6. All right, vertex form and coordinates. We talked earlier about the process of completing the square, and I mentioned that it was most useful for finding the coordinates of the vertex. And remember, the vertex is just the peak of the quadratic, minimum, if it's concave up. And once I find a quadratic in the form x minus h squared, you should be able to notice that if I look at this x minus h squared term, this thing is always going to be positive, right? So I can never have x minus h squared be negative because a square is always going to be positive, which means the vertex has to occur when this thing is 0. And the symmetry of the quadratic is due to the fact that if I take negative 2 squared and 2 squared, I'm going to get 4 both times. So as I move to the left of the vertex or I move to the right, the same distance, I'm going to have the same y value because of this square. Okay, so this allows me to immediately find the x coordinate of the vertex. I know that the vertex is when x minus h is 0, so when x is equal to h. That's the x coordinate of the vertex. And when this is 0, then this entire a times x minus h squared is going to be 0, which means the y coordinate of the vertex is simply k. Okay? Let's take a look at an example. If I have a parabola that has a vertex of 3, 4, and it passes through the point 0, negative 14, find the equation of the parabola. So I know, because it has a vertex at 3, 4, that I can write it in the form some constant a times x minus 3, x coordinate, squared, plus 4. And then, because I know that 0, negative 14 lies on the line, if I plug in 0, I get a times 0 minus 3 squared plus 4 is supposed to be equal to negative 14, which means that a has to be equal to minus 2, because minus 3 squared is going to give 9, so I need negative 18 plus 4 to get negative 14. So this is the equation of my quadratic, and you can expand it to find it in a different form as well. Okay, so remember that the vertex, the x-coordinate of the vertex occurs when the term that's being squared is equal to 0. So 5 minus x is equal to 0, which means x equals to 5 is the x-coordinate of the vertex. And then the y-coordinate is just going to be the minus 3. So I'm looking for 5 minus 3, which is option number 4. Okay. Next, quadratic inequalities. These are a little bit tricky. It's when we're not just looking for the solutions to a quadratic, but where a quadratic is either positive or negative. And you're going to want to start by factorizing the quadratic or considering where the roots are. And then depending on whether the quadratic is concave up or concave down, that will allow you to decide where the quadratic is positive / negative. Okay, so if I have a concave up quadratic, then it's going to be positive to the left of the first root. It's going to be negative between the two roots, and it's going to be positive again to the right of the second root. And it's going to be the opposite for a concave down quadratic. So it's going to be positive between the roots and negative outside the roots. And you've got to be really careful when you're looking at a question whether it's greater than or equal to, because that's going to affect how you write down your answer. But let's do this example. I have negative x squared plus 2x plus 3 is greater than 0. We're not going to go over it again, but we can factorize this quadratic and write it as negative x minus 3 times x plus 1, okay? And because there's a negative in front, it's going to be a concave down quadratic, so a concave down parabola. So it's something like this. And we're looking for where it's positive, which means we're looking between the roots. So we're looking between x minus 3 is a root of 3, and x plus 1 means a root of negative 1. So we're between negative 1 and 3. So the answer is minus 1 less than x less than 3. Okay, so let's go about solving this. So I have the quadratic negative x squared minus 5x minus 6. I'm going to pull out all the negatives and just write this as negative x squared plus 5x plus 6. Okay, and I'm looking for when that is less than 0. And I'm going to factor the inside. So I'm going to do x squared plus 2x plus 3x plus 6, so negative, just factoring by inspection. And then it becomes x times x plus 2 plus 3 times x plus 2. And this becomes negative x plus 3, x plus 2. Okay, so I now have a concave down parabola, and its roots are going to be negative 2 and negative 3, because I have to switch the factors. X plus 3 is 0 at x equals negative 3, and this is 0 at x equals negative 2. So I'm looking for this to be less than 0, which means I'm looking outside the roots, right? So I'm in this region or this region. So everything that's between the two roots, which means I have to go from negative infinity up to 3, negative 3, not inclusive. So I'm going to use a bracket like that. And then from negative 2 up to infinity, bracket like that. If you're not already familiar with this bracket notation, it's just a way of denoting an interval. I use square brackets for an interval that is inclusive, and then normal braces for an interval that's exclusive. So in this case, I want to exclude minus 3 and minus 2 because I have less than and not less than or equal to. So the answer is going to be number 3. Let's do some harder problems, some exam style problems. Part A asks us to find the value of h and k given the vertex that we see on the diagram. So remember, h is going to be the x-coordinate of the vertex, and k is going to be the y-coordinate of the vertex. That means that x minus h is going to be negative 1, h is equal to minus 1, and k is going to be equal to minus 2. Let's see the multiple choice. H is equal to minus 1, k is equal to minus 2. All right. Part B. So I can write the quadratic in factored form, a times x minus alpha, x minus beta. And beta is larger than alpha, okay? My two roots are going to be negative 3 and 0. Which one is bigger? 1 is bigger than negative 3, so alpha is equal to minus 3, beta is equal to 1. And I'm using just the x-coordinates of the intercepts and recognizing that those are the roots. Okay, so alpha is equal to minus 3, beta is equal to 1. Okay, and finally, find the value of a, which is the thing that's multiplying this a times x minus h squared plus k. To do that, I'm going to use the fact that I have a y-intercept at -3/2. So I'm going to plug in 0, x is equal to 0, into my original equation. I'm going to get a times, sorry, not equals, a times 0 minus h squared plus k. And I know that h in part A we found was -1, and k was equal to, we said -2. So I have a times 1 squared, because -1 is 1. And I'm adding -2. So I'm going to have a minus 2 supposed to be equal to -3/2. And 2 is 4/2. So a minus 4/2 is equal to -3/2. A is equal to 1/2. Let's see the multiple choice options. 1/2. All right, moving on to something a little bit harder. I have the quadratic x squared plus k minus 5x plus 5k is equal to 25, has two distinct real solutions. Find the possible values of k. All right, so two real solutions means that my discriminant is going to be positive. But before I think about the discriminant, I want to get this quadratic in the form something is equal to 0. So I'm going to bring the the 25 to the left-hand side. So I'm going to get x squared plus k minus 5x plus 5k minus 25 is equal to 0. And now I know that delta is going to be equal to b squared. So k minus 5 squared minus 4 times a is 1 in this case. And c is 5k minus 25. And that's all supposed to be greater than 0. Okay, so if I expand all of that, I'm going to get k squared minus 10k plus 25 minus 20k plus 100 is greater than 0. And that becomes k squared minus 30k plus 125 greater than 0. Now, you can factor this by inspection by noticing that 125 is 25 times 5. This is k squared minus 5k minus 25k plus 125 greater than 0. Which means that k times k minus 5 minus 25 times k minus 5 greater than 0. And if I bring that all together, k minus 25, k minus 5 greater than 0. This quadratic is concave up, which means that it's going to be positive outside the root. So k has got to be less than 5 or greater than 25. Okay, so that means that I'm going from -infinity up to 5, and it's not inclusive, right? Because I don't want delta equals to 0, which means I have to have option 4. All right, let's take a look at a classic sort of applications of quadratics question, which is a very common theme on IB when it comes to, examining quadratics. And basically, the idea here that we have in this question is we have a farmer who's trying to build essentially 3 enclosures alongside a river. So the farmer is going to have to use his 100 meters of fencing to make all the sides of these enclosures except the one side that's along the river. And we're told that the total length of the fencing is 100 meters. And the first thing that we want to do is try and express the area for all 3 enclosures in terms of x alone. So we can pretty quickly notice that the area of each enclosure is just going to be x times y, because these are all rectangles. And so if I have 3 of these enclosures, the total area is going to be 3xy. 3xy. And the key thing to write this just in terms of x is to use the fact that the total perimeter of the fence has to be 100 meters. And the perimeter I can think about as 3 sections that are of length x, and 1, 2, 3, 4 sections that are of length y, which means that 3x plus 4y is equal to 100. All right? And that means that I can write 4y is equal to 100 minus 3x, which makes y 25 minus 3/4 of x. And if I plug that into my expression for the area, I'm going to get 3x times 25 minus 3 over 4x, which becomes 75x minus 9 over 4x squared. Okay, checking the multiple choice answer. It's not exactly in the same form as what we had. The only difference is that everything is over one common denominator. If I put 75x over denominator 4, that's going to be 300x. So 300x minus 9x squared over 4 is the answer to part A. Okay, moving on to part B. I want to think about essentially the maximum area of each enclosure. And it's very, very important now to focus on this word each. It's a deliberate trick to try and get you to calculate the area of all the enclosures. So basically, I'm looking for x times y, and I'm looking for the maximum x times y. And I found in the previous question that the area was, I'm going to keep my 75x minus 9 over 4x squared form. I think it's a bit easier to work with. And I'm looking for 1/3 of that area, so I'm looking for 25x minus 3/4 of x squared. Okay, so this is a quadratic. 25x minus 3 over 4x squared. I have an x squared term and an x term. And it's going to be a concave down parabola because I have negative 3 over 4 as the leading coefficient a. And a concave down parabola has a maximum at the vertex, which means to find the maximum area here, I essentially have to find the coordinates of the vertex. So the way I'm going to do that is to think about the axis of symmetry, right? So the axis of symmetry tells me the x coordinate of the vertex. And I know that the axis of symmetry has the equation x equals negative b over 2a. In this case, my b is 25, and my a is minus 3 over 4. So x is going to be negative 25 over, and 2a is going to be negative 3 over 2. And, yeah, negative 3 over 2, which becomes 50 over 3. So that's the value of x that's going to make the area maximum. But it's not yet the actual maximum area. To find that, I'm going to have to plug this value of x back into my expression for the area. So if I do that, I'm going to get my area is equal to 25 times 50 over 3 minus, and I'm just going to reset this share so that you can actually see what I'm doing. Let's put that up here. So I'm going to subtract out 3 over 4 x squared. So 3 over 4 times 50 over 3 all squared. Okay, now let's kind of take a closer look at this and try and simplify as much as I can. I'm going to have 25 times 50 over 3 minus 3 over 4. So let's write this as 25 times 50 over 3 minus 3 times 50 times 50. That's 50 squared. And then I'm going to be dividing that by 4 times 3 times 3. And that's the 3 squared. I'm going to cancel one of these 3's with the one in the numerator. So I'm going to have 50 times 50 over 12. And I'm subtracting that out from 25 times 50 over 3. And if I want to make these fractions be with a common denominator, I can just multiply this one by 4 in the denominator and 4 in the numerator, which then means that I have 100 times 50 minus 50 times 50 over 12, right? So I have 100 50s minus 50 50s, which means I have just 50 50s over 12, which is 2,500 over 12. Now, the answer is going to want us to simplify that down because 2,500 can be divided by 4, and that's going to give us 625 over 3 square meters. All right, nice work. This question is one that could likely show up also in calculus, but in this question, I want you guys to do it without calculus. And so I have a function mx squared plus 2mx minus m, and the graph of f has a vertex at point v, okay? So find the coordinates of v in terms of m. That's going to be part A. So let's take a stab at part A. So remember that the coordinates of the vertex, I can think about completing the square, or I can think about finding the axis of symmetry. I think it's a little bit easier to think about finding the axis of symmetry here. So I remember that I have x is equal to negative b over 2a is the axis of symmetry, also the x coordinate of the vertex. So negative b in this case is negative 2m, and 2a is twice times m. So this just becomes negative 1. That's the axis of symmetry. And if I plug that in, I can do f of minus 1 to find the y coordinate. And I'm going to do m times negative 1 squared is m minus 2m minus m. So this is just going to be negative 2m. So the coordinates of the vertex are negative 1 comma negative 2m. And let's see if that is one of the answers. Negative 1 comma negative 2m. Okay, I'm going to start solving part B. I have the line y is equal to 2 minus 4x, which intersects the graph of f at 2 distinct points. So if I write mx squared plus 2mx minus m is equal to 2 minus 4x, this is two solutions, which means if I bring everything to one side and I do mx squared plus, in the x terms, I'm going to have 2m plus 4 times x minus m minus 2 equals 0. This quadratic has to have a delta, a discriminant greater than 0, because it has two distinct solutions. So delta is greater than 0, and delta is equal to 2m plus 4 squared minus 4 times a, in this case, is m, times, and c is negative m minus 2. So this becomes, if I expand 2m plus 4 squared, I'm going to get 4m squared plus 8m plus 16 minus 4m, and plus, if I actually switch the brackets here, m plus 2. And that's supposed to be greater than 0. So I can do, and actually I can be a little bit smarter about this. I'm just going to erase this expansion. It's going to be easier actually if I just take out, I write this as 2m plus 2 all squared, because then I'm going to have a common factor of m plus 2 throughout, and I don't have to factorize afterwards. So I'm going to take out the m plus 2. I'm going to have m plus 2 one time, and then I'm going to have all of that times 2 squared times m plus 2 plus 4m is greater than 0. So this is m plus 2. And this is going to be 4m plus 8 plus 4m. So 8m plus 8 is greater than 0. And because this is a concave up parabola, it means that this becomes 8m plus 2, m plus 1. Roots are minus 2 and minus 1. So m is either less than minus 2 or m is greater than 1. Let's see if that is in the answers here. So from negative infinity up to minus 2, and then from negative 1 to infinity. It's supposed to be in negative there. This time I have mx squared plus 2mx minus m is equal to mx plus minus 5. And that has exactly one solution. So now if I bring everything to one side, mx squared, if I subtract mx from both sides, I'm left with just plus mx minus m, and then plus 5 is equal to 0. This has delta is equal to m squared minus 4 times m times, I'm going to write this as 5 minus m, and delta is supposed to be equal to 0 because I have one solution. Okay, so here I have m squared minus 4 times m times 5 is minus 20m, and then plus minus 4 times m times negative m is plus 4m squared is equal to 0. So that means that 5m squared minus 20m is equal to 0, which means that if I factor out 5m times m minus 4 is equal to 0. So either m is equal to 0 or m is equal to 4. So in this case, I wouldn't have a quadratic if this m, the leading term, was equal to 0, so I must have m is equal to 4. So just when you're writing this on the IB, make sure you say reject m is equal to 0 as mx squared dot 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 would not be quadratic. And therefore it wouldn't have a vertex, and we know it has a vertex. Okay, so that must mean that m is equal to 4. And that is how we do part C. So for these questions, by the way, on the website, when there's no answer to show that, if you scan your work, if you take a picture of your work or you type it into the box, the AI will grade your work according to the IB mark scheme. So this last part, it's a little bit outside of quadratics because we haven't covered function transformations yet. So if you're not familiar with that, it's fine. You can wait for that session. But the idea here basically is that now that we know m, and we found that the coordinates of the vertex were -1, negative 2m, we know that the vertex is actually going to be -1, -8. Okay? And then when I graph this new function, which is y is equal to twice the function, but I put x minus 3 in the argument, x minus 3 is a horizontal translation of 3 units to the right. So I'm going to shift the vertex. I'm going to do -1 plus 3. It's going to become 2. And then I'm going to multiply by 2, so the -8 is going to become -16. Okay, so that is the vertex, -2, -16. All right, beautiful, beautiful. So we are going to move on now to, I think the next stuff is all HL content. So the only part of quadratics that's higher level are the Vieta's formula. And I think everyone here is higher level, but I could be wrong. And we're going to talk more about the sum and product of the roots when we get to polynomials, I think in about 2 weeks' time. But for now, I want you to just notice that if I have a quadratic in factored form that looks like this, a times x minus alpha times x minus beta, if I expand that out, I'm going to get ax squared plus a times alpha plus beta x plus a times alpha beta. And so you notice that the sum of the roots, which is alpha plus beta, and the product of the roots is directly related to the general form of the quadratic, so what coefficients I find. So if I have a quadratic ax squared plus bx plus c, it must be that the roots satisfy alpha plus beta equal -b over a, and alpha beta equals c over a. In this case, I just want you to find, as an example, the sum and product of the roots of 5x squared minus 10x plus 3. So I know according to this formula that alpha plus beta is -b over a, so -10 over 5 is 2, that's the sum. And the product is c over a, so 3 over 5. So remember, the sum of the roots is -b over a, so alpha plus beta is equal to -7 over, in this case, 1. So just equal to 7. So the sum of the roots is 7. Okay? And the product of the roots is c over a, so it's just 10. All right, so I have a problem here that tells me that I have a quadratic equation, x squared minus k plus 2x plus 4k plus 1 is equal to 0, and the roots are alpha and beta. We're told that alpha squared plus beta squared is 34, and we're asked to find the possible value or values of k without solving the equation. So the key here is to think about Vieta, the sum and product of the roots. And the way we're going to do that is to remember our key formulas, which are unfortunately not in the formula booklet, which are that the sum of my roots, alpha plus beta, that's going to be -b over a. In this case, my b is -k over 2, or k plus 2, so it's just going to be k plus 2. And the product of my roots is the last term divided by the first term, so 4k plus 1 over 1, or 4k plus 1. And the trick, the hard part of this question, that once you've seen once, hopefully you'll recognize every time something like this comes up on an exam, is that alpha squared plus beta squared is the same thing as alpha plus beta squared minus 2 alpha beta. Because when I expand alpha plus beta squared, I'm going to get alpha squared plus beta squared with a 2 alpha beta in the middle. And I can subtract out 2 alpha beta to get back what I want. And the nice thing about this is I know what alpha plus beta is, and I know what alpha beta is. So this is k plus 2 squared minus 2 times 4k plus 1. And we know that this is all equal to 34. All right, so if I expand this out, get k squared plus 4k plus 4, then I'm going to get minus 8k minus 2 is equal to 34. So my k squared is the only power 2, so just k squared. The k terms are 4k and negative 8k, so that's going to be negative 4k. Then I have plus 4 minus 2 minus 34 is 2 minus 34, negative 32. Okay, and I'm going to factor this by inspection by noticing that 32 is 8 times, or negative 32, sorry, is negative 8 times 4. So k squared minus 8k plus 4k minus 32 is equal to 0. And that means that k times k minus 8 plus 4 times k minus 8 is equal to 0. And I complete my factoring. K plus 4, k minus 8 is equal to 0. Right? So if the whole thing is equal to 0, it means that one of the terms has to be 0. So either k plus 4 is 0, which means k is negative 4, or k minus 8 is 0, which means that k is 8. So let's see our multiple choice options. We should have negative 4 and positive 8. Here we go. Well done. Okay, so that's all the problems I wanted to go over today for quadratics. So well done for sticking to the end for those of you who made it. This material is probably the easiest of all that we're going to cover in the sessions. It's the foundation for all the other topics we're going to cover, and things are going to get a lot harder as we go along.